Next one is slicing an array. Okay. So what is meant by slicing an array here? Very simple. Suppose if we want to access some part of an array, instead of accessing the whole array, I want to access some slice of the array or some part of the array. In such case, we can go for the concept of slicing an array. Okay. So how do you access in such cases? The general syntax will be, first you have to mention the starting point from where you want to access the part of the array, right? And then also the ending point. Okay. So as we know, this is going to access up to end -1. Suppose if the start is not specified, in that case, it will automatically consider 0. Okay. If start is not specified, it will consider 0. If suppose the end is not specified, then it will consider the length of the array. Okay. So ln of array is considered in that case, which means it is going to access each and every element in the entire array. Okay. Because start is not considered and end is not considered, then it means you're trying to access the entire array. Okay. So this is one syntax, and there is another syntax where you can also specify the step size. So in such case, a start, end, and also you have to specify the step here. Okay. So what is a start? Start is again same starting element that we want to access, and this end means up to end -1 it is going to access. Step is representing the value, how much that you are trying to increment, or step size. Okay, suppose if you want to increment by 2, you want to access the first element and then the third element, then the step size will be 2. If suppose the step size is not mentioned, by default it will consider 1. Okay. If the step size is not mentioned, it is considering 1. If the step size is mentioned, then it is going to consider that particular value. Okay. So let's consider quickly an example related to slicing an array. For this, we have to import the NumPy module. Import NumPy module. So I want to give an alias name for the NumPy module as NP, and consider ARR is an array. Okay, NP dot array of. So let's create a one-dimensional array. The elements in the one-dimensional array are 1, 2, 3, 4, 5, 6, 7. So these are the elements with which I have created a one-dimensional array. Now I want to print partial array, that is a part of the array or slice of the array from this content, which is array of 1:5. 1:5. Now this is going to create an array, and what will be displayed as part of the output. Okay. So writing this statement has created an array. Now you are trying to print a part of this array by mentioning like this. So remember, again, this 1 is representing the starting index, and this 5 is indicating the ending index. So always you have to access less than end. Okay. So let's see how this is going to create an array in the second statement. So the elements that are located inside the array are 1, 2, 3, 4, 5, 6, and finally 7. Okay. And here the indices of this array are, this is at index 0, this is 1, this is 2, this is 3, 4, 5, and 6. Now we are going to access from the starting location. What is the starting location? 1. And ending location is 5, which means you have to access up to end -1 only, which is nothing but 4. It means it is trying to access this slice of the array. This is the part of the array or slice of the array that is accessed using this code, and hence it is going to print the elements as a 2, 3, 4, 5. Okay, starting from array of 1 up to array of 4, because the ending position is 5. Okay, so this is the respective output that is going to be displayed. Now let's consider another example here. Okay, here I'll consider again importing the NumPy module. Import NumPy as NP. Now we can access the array, which is np dot array of. Consider the elements of the array as again 1, 2, 3, 4, 5, 6, 7, just like this. Now I want to print only part of the array or slice of the array. I'm writing like this. Now what will be its corresponding output that is going to be displayed if we write like this? So remember, writing this code will automatically create an array, which is a one-dimensional array containing elements like this: 1, 2, 3, 4, 5, 6, and 7. Now the index, starting index is mentioned, but the ending index is not mentioned. When the ending index is not mentioned, it is representing the length of the array. So the length of the array means you have to access from the starting location 4, which is an index of the array, till the end of the array, which means you can see here the indices are like this: 0, 1, 2, 3, 4, 5, 6. So what is the starting index here? 4 is the starting index. So till the length of the array. Okay, it means you have to access up to here. Length of the array will be 7, ending point will be 7. So which means you have to access up to less than 7. Okay, index less than 7 means you can access this part of the array. So you will get output as 5, 6, 7 in this case. Okay, now consider another example where we can also write step size. Okay, so let's import NumPy module. Import NumPy as NP. ARR is equal to np dot array of. Now in this array contains elements like this: 1, 2, 3, 4, 5, 6, 7. Okay, so let's print array containing elements as 1, 5, 2. This is the syntax. So what will be the corresponding output produced by this code? First, remember, this is representing the start, this is indicating the end, and this is indicating the step size. Okay, it means it has to increment by 2 positions, which means in the entire array, 1, 2, 3, 4, 5, 6, 7, these are the elements. So indices are 0, 1, 2, 3, 4, 5, 6. The moment we write start as 1, it means we are trying to access this location, right? This location is captured or not. This element 2 will be displayed, and later it has to be incremented by 2. It means it will go to the next location. Okay, and its index is 3, which is still less than 5. So this is going to be captured and it is displayed. And then incremented by 2. So this time we are referring to index 5, but you can access only less than index 5. Okay, so the output will have only 2 elements, that is 2 and 4. Okay, like this.